here. Okay, down here we have the same situation. Now, we can't cross multiply down here because I have two pieces right there attached with a plus. And remember that in order to be able to put those together, I really need common denominators. So what my strategy here is going to be is to get all the pieces matching. So I see two different pieces already present. I see an x plus 4 and an x minus 4. So the easiest thing to do here is to actually just put that same combination on the bottom of every single one. Remembering, of course, that if I write one on the bottom, if I had to add it, I must also add it to the top to keep the fraction balanced, because essentially I'm multiplying by something on top and bottom. So, for example, with the 1, I technically had to hit the top of it with an x plus 4 and an x minus 4. Same thing over here. This x minus 4, I had to add a plus 4, so I had to put that with the 12 as well. X plus 4. In other words, let's write this a little neater. We have 12 times x plus 4 is equal to x plus 4, x minus 4, plus 14 times x minus 4. And notice I did not recopy the denominators, because since they all have matching denominators, I can cross them out. And of course, crossing them out, I do need to make some notes to myself just to be safe. X cannot be a positive or a negative 4. So I'm going to say note. If you get one of those solutions, it is invalid. Okay, from this point on, we don't forget our note, but we just go ahead and do regular algebra. So in other words, I'm going to FOIL this right here. Let's see. Let's give me the difference of perfect squares, isn't it? X squared minus 16 is what we'll end up getting, because we'll have a plus 4x and a minus 4x, and they'll cancel out. And over here I've got plus 14x minus, let's see, what's 4 times 14? $56 is equal to 12x plus a 48. Now, we have x's on both sides, and we have lots of simplifying to do, because remember, when I have an x to the first and an x to the second, I do need to factor or use some other method to solve besides just isolating the variable. So I'm going to try to get everything on one side, hoping that I'll be able to factor in a second. Let's see, that's here. So now I'll have x squared. That minus 16 needs to go with the other negatives, doesn't it? So actually we have a negative 16, a negative 56, and a negative 48. So we have, let's see, plus 2x minus 120 equals 0. And then we can just factor that. Or, I mean, at any point you can look at the graph to see what's going on. I'm going to say I'm looking for two numbers that multiply to be negative 120 and that add to be a 2. So let's see, playing with that in my calculator. I'm getting a 12 and a 10. I'm not sure why that wasn't. Okay, and let's see, I need a positive when I add, so I'll make that 10 negative. In other words, over here I'll split my center term using the grouping method into x squared plus 12x minus 10x minus 120 equals 0. Now that I'm grouping them, I'm going to come back over here since I'm out of space. I'll say, okay, let's see, that's x, looking at the first two, times x plus 12. Second two, I'm going to pull out a negative 10 times x plus 12 equals 0. In other words, x minus 10 equals 0, x plus 12 equals 0, and I'm getting two solutions for this. An x equals 10 and an x equals negative 12. Number 22. If y varies inversely as the fourth power of x, And then it keeps talking. And y equals 4 when x equals -2, then blah, blah, blah. Then find y when x equals this. So this is actually a multi-step problem. The first thing I want you to remember is, what is inverse variation? What does that mean to me? There's two types of variation. We have direct variation, which is when you have something like y equals, some constant k times x, maybe to a power, who knows. But where they're on the same level, that's direct, okay? When one goes up, the other goes up, etc. Indirect, or inverse variation, is basically when they're kind of like opposites. So in this case, you still have some constant, some different amount between them, but when you look at it, you'll notice the x is on the bottom of a fraction while y is not. And of course, x can still have a power on it. So the idea in inverse is that they're like opposites, okay? One's on normal ground while the other's below. Opposite, inverse. While with direct variation, they're straight across. You have a y and an x on the same level. So here with inverse variation, the first thing that you need to do is to actually find that model. So we'll use the words that it gives us. It tells us that there's an inverse relationship, so immediately you should think fraction with x on the bottom. It tells us the power of that x is the fourth power, so I'll put x to the fourth. We know there's always some constant you just throw on there because you have to solve for this, whatever it is. It's like solving for slope or something, for this constant that goes into the equation. So this is the outline that it gives us in those first few words. The next statement tells us how to solve for k. So step 1, get your equation. Step 2, use the information you have to solve for k. So in other words, now I will plug in my y equals 4, so I'll say 4 equals k. Let's see, x is -2. Be sure to put that in parentheses to the fourth. So let's see what I get. -2 to the fourth power is 16. So I have 4 equals k over 16. To get k alone, I'll multiply by 16 on both sides. So 16 times 4. It looks like I'm getting a constant k equal to 64. Now be careful, guys, we're not done. The actual question comes way into this problem. It comes way back here when it says, okay, well now, what is y when x is 0.5, or 5/10? So the idea is, this problem number 22 has 3 steps. The first step being, hey, understand the general form. Second step being, solve for that k. Third step being, now that you have your formula, which let's write our formula, y is equal to, we know that we have a 64 over x to the fourth. So now that we have this formula, use that given that x is equal to 0.5. So in other words, y is equal to 64 over 5/10, or 0.5, however you like to call it, to the fourth power. What is y? So let's see, 64 divided by, be careful with your parentheses. If you type this all in at one time, I'm getting something like this. Okay. So not too challenging as long as you can remember that inverse means it's going to look like that every time. And if you can remember to keep going, so first to use the 2 numbers you have to get the missing letter. The missing letter is always the one that is not x or y. It's always like an A, B, C, K, something like that. So solve for the missing letter. And then once you've done that, anybody I think can do it from this point. You just sub in your x. Number 23, the average number of vehicles waiting in a toll booth of a superhighway, is modeled by the function, there we go, where x is the quantity between 0 and 1, known as the traffic intensity. To the nearest tenth, find the average number of vehicles waiting if the traffic intensity is 8.1. So the main thing here is you need to figure out, is traffic intensity a y or an x value? So let's read it again. And that was 0.81, excuse me. Let's see. Average number of vehicles waiting is modeled by. So N is the average number of vehicles. Notice that a lot of our problems are just figuring out what the letters stand for. That comes up on almost every single test. X is something between 0 and 1 known as traffic intensity. In other words, when they tell us traffic intensity, they're really telling us x is equal to 0.81, 81 hundredths. So number 23 is really nice. All that you need to do is plug in x into your equation. So we have n is equal to, the average number of vehicles is equal to 81 hundredths squared over 5/10 times 1 minus 81 hundredths. So I literally just plugged it into the equation. Let's see what I get. When I key it into my calculator, I always do it all together. I'm just very careful with parentheses. I do this so that I can proofread my work really easily. I'll put that up just in case you can see some of it in just a second. So in other words, when I key it in the calculator, I literally used parentheses here. I also used parentheses on the bottom twice just to clarify to the calculator what goes on the bottom of my fraction so that it wouldn't divide anything incorrectly. And I'm getting about 6.9, which is C. So we'll say C is the answer to 23.